All right. Level's good. Welcome back to another week. I'm here, your host for tonight, Agent Ultra, and we are going to hack on stuff in Haskell, the programming language Haskell. What we're going to be working on tonight is basically TigerBeetle. There's a database called TigerBeetle. It's a financial transactions database, kind of specialized around that. They don't have a Haskell client, so we're building one. Yeah. So that's what we're going to be doing. We're a bit of the ways along, so welcome, and hope you have fun hanging out here. So if you have any questions about what I'm doing along the way, of course, feel free to pipe up with your questions or whatever. I'm happy to be distracted and take questions and help you understand what I'm building and what I'm working on, or just chatting or whatever. Backseat programming is fine too. All that stuff. So, without further ado, let's get into it. I just gotta fix up this PR, and then the latest thing that I've been working on will work. So we're getting to the point now where I can initialize the client, at least the pointer to it, and disconnect to it cleanly and get the server to recognize the connection and stuff like that. So that's working nicely. And this PR here just updates our Nix environment, our Nix Flake stuff to build TigerBeetle from the same source that we build the client from so that they can connect. So right now, that's the current problem I'm running into, where the client connects, but then immediately gets disconnected because it's not the right version. The version that comes packaged in Nix packages is just too old. So we just gotta update this and get this going. So I'm gonna check out that branch. What was it called again? Sorry, it's my own branch, I don't remember. Nix package TigerBeetle, yeah. We're gonna create one, origin. I have to fetch first. Oh, of course, sorry. One of these days, I keep saying that. I've been saying that for months, that I'm gonna fix this, but I keep forgetting to. Something up with the VM that I run Linux out of here. But all good. It is sorted now. Okay, and let's pull that in. Okay, that's the one. Okay, and the feedback we had on it, pretty minimal, just some cleanup that I forgot to clean up. And we'll get that merged. Okay, pushed up. Okay, we're not going to rebase on it because the commits are kind of messy, so, but there's not too many of them, so we'll squash. That's all good. Okay, cool. So what that change allows us to do now is build the... So we get the source from our flake as an input. And I created a new package for TigerBeetle based off of the libtb client Nix package we have there. All right, and all it does is basically the same stuff, except instead of compiling the client, it compiles the database. What's up, AdPex Twin? Let me guess. Frog. So we should be able to, yeah, right, I'm using DRNV reload there, sorry, wrong key binding. But we should be able to rebuild that environment now with those matching things. And then I can show you the connection stuff and that all working. And then hopefully we can go from there and start expanding out the library. It's kind of a black triangle moment. Projects, TigerBeetle HS. There we go. So that might actually take a little while to run. This is going to compile everything. TigerBeetle in the whole 9 yards. Okay, so in the meantime, while that's going, well, there's kind of one other thing I would like to be able to do, and that's, and I don't know if I have the Nix foo to be able to do it, but I want to be able to set up a quick little script that runs the Cabal REPL with the paths to the libraries all set up so that we can link to it in the REPL. Because I like to be able to go to the REPL and like, you know, play around with stuff as I'm building it. But I don't know how do. Maybe we can do it in this install phase here where we can set. I wonder if we can set LD library load path in here. We might spend a little bit of time trying that out because it's really handy to be able to do that and not have to like find the path that the library is installed in and then set the link flags and everything like that on Cabal REPL in order to get that going. I guess in order to do that, well, we need the shell first. But in order to do that, well, to really test if that's going to work, we can just test that in the shell once it's up. Okay, well, while that's building, why don't we look at a little bit at the library? See where we're at right now. Okay. Okay. I'm going to switch over to... raw client? Or did I merge that already? I think I already did, actually. Oh, nice. We're gonna get some CI going and stuff. That's gonna be sweet. So it should be actually on master now. Yes. Yes, yes, yes. Now, we just did a little bit of cleanup on the client there and added the address and cluster ID modules. So we moved those up because they're going to be shared a little bit the raw layer, maybe even the high level client interface. And that's just a format commit. And then cluster ID. We just fixed the cluster ID here. Some of the byte offsets were just wrong. So that should be all good now. Oh, okay, cool. We're built now. So now my TigerBeetle version. It's evaluating something, I guess, now? I don't know why. There we go. Yeah, so 0.16.23. Not 16, not 22.3. Depending on how you want to say it. Which matches our flake. Oh, not 3.3. Maybe not. Maybe. Is that still the Nix Flake one? our next packages one. Because that one was too old. Oh, maybe that's just what the version is being reported from master, I guess? I mean, I'll find out in a minute once I fire up the REPL and try this out. 0.3, they say 0.32. This is still reporting 2.3, so I don't know. We'll just remove this TigerBeetle database that we have built, potentially on a prior version. So in order to start up our TigerBeetle database, I have these handy little setup scripts. So it's just going to generate a test database and all that stuff. So we go into source database, TigerBeetle, and raw. So raw here, just kind of a nice wrap, just wraps the FFI layer stuff, gives slightly better types where it can, but tries to map one-to-one, mostly with the FFI calls. Just because, like, the FFI layer stuff is kind of clunky and ugly to work with, and this just provides a slightly better interface to it for the higher-level client to use. A similar pattern to you might find in other libraries like SDL2, wrapper, and stuff like that. Okay, so that's the database built. Now we can run the database. TB run. Okay, and then we can follow that with .log if we want. Cool, so it's running now. Okay. So the main thing with the raw layer right now is the client. Right now I'm defining it as, I'm just got this type alias called client pointer. It's a foreign pointer to the TB client. And we kind of broke out these little helper functions to initialize, called the initialization functions. That reason why it's a foreign pointer is because the pointer that you pass into TB client init in the FFI layer, in the C library interface. That pointer is really technically owned by the C library, by TB client. So foreign pointer allows us to like allocate space for that object and that reference, and the GHC runtime will make sure to call finalizers for us to clean up anything and stuff when the last reference to the pointer goes out of scope. A lot of the normal allocation stuff in Haskell does it with like a block scope. All right, so this allows us to kind of like break things up a little bit and compose things from smaller bits. Here's a foreign pointer like this. So the malloc foreign pointer allocates the memory. So there's like a little bit of an array of data that will get filled in by the client, which is like the client ID that the library will use to identify this client request. And then dinit client just uses with foreign pointer to call our foreign function interface to deinitialize the pointer. So I was hoping initially when I used the foreign pointer stuff that we could run dinit as an action on it. There is still a way to run arbitrary finalizers that do arbitrary IO, but for the reason that I thought a suggestion to be able to add user code that could like to the library to run arbitrary IO. It turns out running even our FFI code obviously is doing IO, and that's a no-no as well in plain old like foreign pointer finalizers. So there is a way to do it though, with a different module called foreign.concurrent, but I'm kind of hoping that won't be super necessary. I'm thinking at this point now that once we get this library going, that we'll get, we might be able to use something like some type tricks, like phantom types and stuff, to be able to make sure that the client layer doesn't accidentally try to like use an initialized or connected client pointer with one of the functions in the interface, and that like dinit can only be called with an initialized pointer, and you can't dinit twice on the same pointer, that kind of stuff. Preventing just little mistakes like that. But it'll be up to the client layer to call dinit manually as it needs to. But users who are importing the library and using it as a library won't have to worry about initting and de-initting stuff like that. We'll have a nice Haskell interface for that that'll bracket everything. We'll just bracket one layer up though. Okay, so in order to actually get this connected and set up a REPL for it, got to do a couple of things. First, I need to find the location of the TV client library that we just compiled and installed. So I don't have like a good... This is why I kind of want to find a way to do this with Nix so that this script can be just generated because it knows all the paths and stuff when we're building the dev shell. So otherwise it's going to get a little bit annoying. So that find a Nix store TV client. Those are the C sources. Got two paths here. Could be this one. I guess I can check the timestamps on them, maybe. Nah. Probably. Yeah, all gonna be like that. All right. Well, very helpful, Nix. Thanks for not giving us a real good M time here on the files that you created. Oh, maybe there's a command to like find out what the path is. Nix CNV. Nixeval channel package outpath. Okay. Something like that. Actually, it might not even need to use Nix to generate the script if we can just query it like this. That would be super dope. Especially if we can find the exact Nix-store-q-graph. I can't paste, but var run/current system. Okay. Not in the Nix store, because that doesn't mean anything to me. That was a Nix Awe stuff. Yeah, adpex. I could do that if it was on the binary, like TigerBeetle. Which apparently my terminal is... Oh, maybe I'm not in the projects. I mean, that's why it didn't work. Like if I did which TigerBeetle, it shows the store for the binary. Maybe that's the same. Well, that's why it's 2.3. Interesting. Oh, it's still the same. But I need the library binary path. The path of the binary, the library. All right, maybe I'm not Googling everything. Nix, shared library path in shell. So like we could maybe export LD library path and add the path to it in the Nix package. But like it's not putting it. It's not creating library path there for us. Oh, package config maybe? TV client seemed to work. Oh, Nix LD flags? Nix LD flags is one thing without the underscore. Oh, okay. Yeah, our path. Good. FFI, ELF utils, GMP. And curses. And libtv client right on the end there. Okay, that's good. That's what we need. That path. Maybe there's a way I can do this just for firing up Cabal REPL. Cabal REPL dash GHC options and GHC options dash L TV client. So I have to fire it up like this in order to get it to link the library in. Yeah, all this stuff needs to be cleaned up, but if all goes according to plan, we should be able to import database.TigerBeetle client, database.TigerBeetle client.raw, and database. I think we're going to need to create our callback. Database.TigerBeetle internal.ffi client and foreign.storable. Oh, not client.raw.client. My bad. Oh, okay. I'm going to have to type that all out again. Because apparently the terminal on this thing is weird. Okay, database, raw.client. Database, TigerBeetle. Internal FFI client and foreign.storable. Okay, cool. So our callback, we'll make one of those. The make completion and callback. And that'll be packet pointer 2, 3. I think it's got 5 arguments. All we're going to do is peek the packet pointer and print it. I did mean just 2 E's. Oh my gosh. Make a completion callback. Peek the packet pointer. Peter. Okay, callback is made. What is the type of it? Let's make sure I got all the arguments. Okay, function pointer, TB completion callback. That's good. I think we'll probably get something weird if it's not right. The next part. Right, we get a client pointer by calling this function here, init client pointer. Okay, initialize it with init client. All right. So I'm going to call init client. And one thing I recently learned is that init client echo doesn't actually, like, I thought it was a way to connect to the server that makes the server echo everything that you do. It's not. It's just to test your foreign function interface. It just makes the C library echo everything. But since Haskell takes over the handles for the standard in and standard out, like, streams and standard error streams, you don't see anything. So we might need to do something with that to make that actually be useful. What you actually want is just init client. All right, so go back down here. So a client takes our cluster ID, will give us 0, our address, which will give us 3000, and our completion context callback, or our completion context, which will give us 0 for now, and our function pointer. Ah, okay. So there is something going on here with the way TigerBeetle is being compiled and set up in the environment. This is the error I've been seeing. All right, so it connected. Right, got a connection. This is data filled in to that array by libtb client, the C library, the client ID, which is good. Then it says on request, ignoring unsupported client version too low. So the client we're connecting with, the version is too low. So it sends us the eviction message. So this here is like the print from our callback, printing what we just peeked out of that pointer. So the data in there is this message here. So our cluster and the TB client are two different versions, which isn't right. They should be the same. So we're gonna have to fix that in order to get this to work. But that's the general gist of it at the moment, where we're at with the client. So connecting, getting messages, getting our callback from C into Haskell, right? Passing a pointer to a Haskell function, pointing a function pointer to a Haskell function to C, and getting in C calling back to that same function in Haskell is pretty cool. So got all that going. Okay, now it's just our environment's wrong. It's like the version of TigerBeetle we have is not right. So we're going to stop following that. Okay, so let's look at our flake. Maybe I missed something there. Oh yeah, default glibc. Program, DynamoDHS, checks, default libtb client, like nothing defining that we should have TigerBeetle in here. Except this. Build inputs. Okay, if I get rid of that, I probably should have gotten rid of that. Okay, let's try that. DNV reload. Because what I want is actually from our package. Get rid of that actually. Fetch. Well, that would explain things. Dir. Anyways, so I just did a long demonstration of the error I was getting before, and now the pull request has been merged into my local master. So hopefully that's right. Not quite, no, not what I was expecting. No, let me garbage collect. Okay, let's still in here, so we should probably get rid of that. Okay, well, it's building, so we'll just look into this stuff. Anyway, so once init client's working, then the next step the thing I want to work on tonight after that, once we get that going, is building up a little bit more of the higher level layer by maybe we'll try that phantom type thingy. Maybe that's what we'll do. Okay, so okay, that's looking a little more promising. For some reason it's hanging, trying to... Oh, non-version. That took a long time, TigerBeetle. What's going on with that? Okay. Let's delete that database. Okay, TB setup. Okay, let's just tail, or let's run it. And just tail that log. Oh, address in use, okay. Yeah, that's me, my bad. All right, we're all running on the latest, well, the latest release that we're building against, finally. So all this stuff I did before should now hopefully just work. How did we find the path last time? It was index LD flex, that's right. Alright, Cabal, REPL, GHC, options equals that GHC dash options dash L TB client. that. Make our CB client. Okay, and enter our client pointer. Init the client. Good. And we're not getting the disconnect, which is a good sign. So we just jump over to projects, TigerBeetle HS. We should be able to tail that log and see the connection, and we're just sitting here happy. Tail f dot log. Cool. Okay, we're getting wrong cluster. That's something, but it's not disconnecting us from the wrong version, but it's saying wrong cluster. Okay, cluster ID. Could be something with serialization on cluster ID, still. It's the only thing I can think of that would do that. Let's create a little committee commit though for the fix the flake.nix here. I'll just push it right on master. Sorry, everybody, but that's what I'm going to do. We're going to update flake.nix. Ruin nix packages TigerBeetle. From shell outputs. Okay, so that part's good. That works. That's nice. Cluster. Don't like that we're getting these messages. So let's, maybe we're going to work on cluster ID tonight and sorting that out. Okay, so this is our high-level module. The cluster ID, it's a wide word 128 from the wide word package. So like 128-bit numbers, basically a UUID kind of thing that can hold a UUID, but 128-bit numbers represented by two 64-bit integers. One's the high bits, one's the low. I'm guessing that's what the convention here, high and low, mean. It's getting this kind of big number. We passed in 0. And the way this gets marshaled over the FFI is done in internal FFI client cluster ID. These functions here. So with cluster ID, pointer takes our high-level cluster ID with the wide word 128 in it. Callback function to an array of word 8s. in IO. All right, and what we're going to do here is we get the pointer to that array, we poke into it, cluster ID dot wide word. Poking cluster ID takes an array of word 8, so array of bytes there, and a word 128. And what does it do with that? It pokes the LE first, below 64 bytes, does an offset from that 8 plus pointer, the high. Google plus pointer in bytes. Okay, advances the address by the offset bytes. So kind of like what you do in C, right? Okay. So one whole word 8. Or 8 bytes. Is that right? Yeah, 64-bit unsigned word type. Yeah, 8 bytes. Yeah, that should be right. Okay, so 8, 16, 24, 32, 40, 48, 56. That's 5. It's probably shifting these. We don't need to do these shifts. At 0. I think that might be it. 16, 24, 32, 40, and 48. Okay, so reload everything. Okay, so we compiled our cluster ID FFI there. Okay, so it got picked up that change, as you'd expect. Let's get that tail going. And let's get everything loaded up again. Make our callback. Init our client. Okay, got a collection there. Still getting this wrong cluster. Maybe it was fine. Okay, but we should be able to deinit client as well. Let's try that as well, just to do the cleanup, see the cleanup message come up. Client, client. Oh, what did I call it? What did I accidentally? No. What did I call it? Did I accidentally call it CB? No. Okay, we're just gonna leave. Okay, cool. So that handled it gracefully. Cool, cool. All right, awesome. Okay, what I want to try is... I think I just called it init client without binding it. That's what happened. Okay, get our imports. Callback. Now we call init client with our cluster ID. I'm going to try giving that number there. Address 3000. Our completion context of 0, but our callback function pointer. However, client is a write. Okay, that's good. And no error messages. Okay, so it created a client ID for us when it started up. I guess it will. We need. Okay, so the client serialization code, I guess, was recognized well enough there. Cool, cool, cool. And then I'm going to import that so that I can just do either on it, because I forgot to do it in the Rebel. So on the left case, no. You know what? I will. Yeah, it's fine. We know we can handle it cleanly when we shut down without de-initting. Technically we should probably, but cool. Okay. I guess the only thing I'm not sure of now is, like, did this change actually do anything? Well, it seemed to work. I'm gonna stash it. create a branch. I'll call it cluster ID. We'll put it in review. Stage that. Done. Update internal. FI client cluster ID. Set shift offsets. Shift R from 0 for first byte. Starting from 0 for first byte. Okay. All right. That's pretty all right. So next then, let's get the client. Let's get the cluster. No, the client. Okay, will this buy us anything? Will this help us? So the phantom pointer trick, if you haven't seen it before, let me just briefly explain. The idea is that we use a type parameter on the left-hand side of our definition. It's the left-hand side of the equal sign. Right, and this normally signifies like it's a polymorphic type variable. Right, so the caller can decide what type that should be, or what type that is. Right. When we write a function that wraps around that A, we can say like, oh, it's some kind of type, some kind of polymorphic type. So A would stand in place for like whatever type the caller ends up making it. However, normally you would see this A on the right-hand side of the equal sign as well to be used in the definition. Like if we were to create a tree type. Right, we don't know what's in the tree, but we do know that we can have a node of A or a leaf has no A. Right. A is on the left side, also appears on the right-hand side. When it doesn't appear on the right-hand side, like in our client pointer example here, right, it's called, we can call this a phantom type variable in that it only exists in the type level language, the type level of Haskell. That's expressions that look like this in the source language. But there's no values of it that are like in the actual like values of the type. So it's a phantom type variable. And this could be useful for things like making sure you write functions that take client pointers that are only, say, initialized. Right, if we allowed empty data constructors, uninitialized, and deinitialized, right, these could be the different states of a pointer, a client pointer, right? Init client pointer could now take a client pointer of, right, uninitialized, or sorry, it returns a client pointer, sorry, of initialized, no, uninitialized, yeah, that's right. So we might want to remove init from the name and call it like make client pointer or create client pointer, but it returns it uninitialized, right? And now, like, GHG is going to complain at us that this doesn't, the type variable isn't filled in here for this. So dinit client, for example, would have to take a client pointer of initialized. How do we get a client pointer of initialized? Where do we get that from? All right, well, we're going to get it from init client. All right, so instead of client pointer here, again, it's got to have a type variable attached to it. So we'll do client pointer initialized here. And then dinit, what's that going to return? Well, that returns a TB client status, so it kind of eats eats up the client pointer. Right. The I think this is the weakest part of this, though, actually, now that I'm looking at it, is that the goal of introducing this phantom pointer thing is that, this phantom type variable, is that we don't want to be able to use a client pointer after it's been deinitialized. We want to be able to, like, say it can't be used anymore. That only works, sort of, if we returned a new client pointer here with our final state deinitialized. Right. But we return the status of that call, not necessarily the new type. And so I think what could happen with this is that we could have code, hypothetically, right, that calls like some connection setup code here, like our cluster ID and our address, like we're doing at the REPL, for example. Right, maybe calls this function, this kind of IO action, or like monad action within our with client here that gets a pointer, gets a client. Or maybe it creates a client like this. Maybe the high level code won't have to worry about this, but if I was implementing with client though, what I'd want to be able to do is not be able to pass that client pointer that I get at the hop with a client pointer. Right, and then like dinit client with client, and then call this again. Right, this would be bad. Potentially. It might not be that bad in practice, but I want to be able to prevent that, make that a type error. But I don't think this is going to be the way to do that. Yeah, well, yeah. We'll just have to be, the users won't have to worry about it. It's more for our efficacy, so maybe not super important actually. Because we're going to be implementing this, and like maybe we can just be a little careful. Famous last words, I suppose. Okay. So what next? Well, let's now we got that set up. Let's go to the higher layout level. So that's in database TigerBeetle client up here. Let's get this stuff sorted out. So we have a high level client that basically just connects and doesn't really do anything, and then calls our cleanup function, like brackets everything nicely, so that our client gets cleaned up when it leaves. Maybe when it leaves scope. So the kind of stuff I was writing in the example, let's just get rid of all this. Was, yeah, cluster the type. Let's just focus on the type. Was cluster ID with address, and then it had an IO action that took the client, right, and did something in IO basically. At least in that case. However, we think what we really want is maybe something like client. Monad IO M. Let's make it a little more general over the monad here. And that would be M unit as well. Music died. Let me see if I can bring that back. How we doing tonight, chat? Everyone? Atpex got a little quiet. You still there? More importantly, am I still here? It's just Pretzel acting up again. Alright, we'll have to address that in a little bit. Hopefully it'll come back on its own. It does this sometimes now. Okay, so if we were trying to implement this, we get our address, we get our cluster ID, we get our action. So client rep was what I was going to wrap the raw client pointer in. I was just going to new type wrap it. Alright, music's back. Sweet. So we would call the raw layer in order to get the client pointer. So we're going to pass the cluster ID in here, pass the address in here. We still need something for the callback and the completion context. So the completion context, I think, is how we tie together, because like you notice how we give the callback, the C library calls our callback with the packets. And I think completion context is how it maps the responses to the requests. So we'll have to generate those numbers as we go, which is why kind of like we're implementing the state here. We have this state T of client state. So eventually we're going to have like a mapping to request completion context that'll map the initial packet we send, the request packet, and the response packets for that request. And then apparently like some messaging and like error type like warnings and stuff that we get from the server that probably aren't tied to a specific request. Okay, so let's just do like a dummy callback like we did before. That's probably going to be an FFI, or yeah, FFI. No, raw. No. Burp. No, I don't want to be calling FFI stuff directly at this level. Yeah, we almost want something exactly like this. What do we have already? Almost? I don't know that we're going to need, like, the TM vars and stuff. Like, the same structures, maybe not in IO. For modifying the state, because we kind of have, like, that's what the state T is for. But the right idea, anyway. But for now, how do we, that gets a client state. How's this well, that just sets it up. It doesn't actually run it. Okay, so with client does it. Okay, they just call it here. Okay, so I'm going to need like some kind of raw layer kind of function for this to maybe as a placeholder. Maybe put it after for init client. And callback. And that's literally just make completion callback. It looks simple now, but we're probably going to do stuff like that other function later. I'm just going to leave it that simple for now. That's all we need. We'll just do this like we did in the REPL for now. Packet pointer, number 5, peak, kind of low level, print. I'm just gonna add that for now, but the import to foreign.storable with the intent of getting rid of that. All right, so then we pass CB there. And then we can wrap our client ref over that using fmap. Okay. That doesn't make any sense. It should just be client MA. Okay, so then to take our client action. Now that we have everything initialized, we should be able to run client, call it client action. That's not the end of the story. Then we need to peel off the state T from that. No, the resource T. Booming, complicated, whatever, you're banned. And reported. Don't sell me followers. People need to stop doing that. Okay, so we need the resource T runner. I think this is the one we're using. Remember that? Resource T. Run resource T. Alright, so resource T just unwraps the MA and gives us the MA. Takes the resource T layer off. That's not the end of the story. We got our accept T. Unwrapping to do. Same thing. Yeah. So the runner here gives us our MA, but it does something with the E here in that it wraps it in either EA as return value, which would be our state T again, I guess. Yeah, so that should be fine. So run accept T. And then our state. And then that should get us back down to IO or monad IO, which we run in as the base monad. State, so just to show that, there's a bunch of runner functions for this one. Depending on which one you want, which value you want to get back from running the state. Alright, so run state T gives you both the state and the return value in a tuple. Eval gives you back just the return value, which is probably what we want. And exec state gives you back the state. Okay, so eval state T. Now, eval state T has to take in our state T. Yeah, which we go. Oh, and the state S. So we actually need to flip that around. Just use the handy dandy flip trick. And our state here, which will be client state with our client. And then once we run the action, we deinit. And this will be... We have to get the client ref out. I put a get client, raw client, yeah. Like that. Okay. Does it build? close that follow for now. We'll get GHCID going up so we can make sure this all compiles cleanly. And then hopefully we can just test it. How do I close these? Close all other panes. That's nice. Close all other panes. There we go. Yes, sweet. Parse error. Oh, that's... Yeah, that's wrong, but this shouldn't be. Maybe it is. Right, we get either as a result. So if we pattern match on the results, we want to pattern match on it, or just return it for now? Let's just return it for now. We'll DIN it and return either. Either raw client init error or raw client pointer is what we get back. We kind of want something a little bit more high level than that. So let's fix a to unit in order to do like that. Then we can get rid of that. No, we still need result because we got to return it, but we want to DIN it first. Right, get raw client. And technically, DINIT also returns the status, like did we clean up whatever properly and all that sort of stuff. Just gonna ignore that for now. And then what are we gonna return? Pure results. Raw.DINIT client. Right, so we've got to map over that. Let's get data.byfunctor. And well, bymap to client error and const unit, or just ID. Actually, just ID in that case, I think. And result. Okay, we don't have that function in scope, so let's bring it in. So we'll need to like actually map the low-level raw errors to high-level errors. I'm just going to make it simple right now. Just a single constructor with nothing in it, just that there was an error. Or maybe so that when we're testing it out, we can see it. Oh, we already have client error? Oh, we do. Okay, cool. I don't have to specify it twice. For testing only, remember to remove. Raw. Sorry, not client error at the raw level. What did I call it? Oh, we just don't export it. No problem. Okay, what am I doing here? Submit request. Sorry, client init error. Okay. So at the higher level, we're gonna do client error. And that's the only one we have to deal with right now. Maybe dinit errors as well. Mm-hmm. That's not what I was looking for, GHC. Let's bring it closer to scope here so it can figure that out. Oh, right. Client ref can't fmap over that. We get init results. And then we have left init error. Or we get right client. So we could actually go back a little bit, backtrack here, go just a unit. Yeah, I don't know if we want to actually return, like, do a runtime error there or what, but probably fine. Leave it that way for now. Okay, and then what do we got here? 64 on the result. We expected a client ref. We got actual raw client pointer. Okay, yeah, because we need to wrap that. And 65. All right, result now is also an either. So this will be client action error. Otherwise, it was successful. Okay, yep. We don't need to pass that like that. I don't know. Maybe don't need to, just pure result. And no, just pure unit, sorry. You're right. And it doesn't know that this is necessarily IO, so got to wrap these in lift IOs. As well as here. Hmm. Did I say IO somewhere? Oh yeah, lift. I guess the lift IO call makes it that. Yeah, why isn't that just running? Oh, did I get the order of these wrong? Maybe I got the order of these wrong. Or is that resource T forcing that actually? So the issue here is that the inner monad M here from resource T is demanding monad unlift IO. Because this function here wants to run a resource T. Yeah, so it wants monad on lift IO. We only have monad on IO. We're not running monad on lift IO. Which means we got to buy into that ecosystem in order to use this, I guess. So the reason to use a library like resource T, and what I was thinking when I first pulled this in and kind of spec'd out this transformer stack was that these actions here in resource T, like allocate, take an IO action of A and a free action that releases the resource. And then perform some allocation, and then automatically register a cleanup action. And it handles basically asynchronous exceptions. So like things that could go wrong by calling things like foreign libraries that own resources, right? If that crashed for some reason, right? Or all the myriad things that can go wrong when communicating with this foreign library that like lives outside of our address space, like is dynamically mapped into our address space, but still like foreign code. I was thinking like this would be pretty helpful. All right, because we could be running multiple such requests per thread. All right, you know, initializing clients and all this sorts of stuff. And one of those threads crashes, we want to make sure that it gets cleaned up properly, right? Could be useful for that. But we do have to run in monad IO. No, not just monad IO. We have to run in monad on lift IO, which is a little bit different. That comes from... Actually, does it come from resource T? No, control them. Yeah. Oh, weird. Okay. Maybe we already have it. That would mean I could just... I should have it in scope. Do I have to add that as a class? So I do that. monad.io. Okay, that might not be it. Yeah, that might work. GHC, that might work. Maybe. Left.io. Client M. I'd imagine monad on left.io implies monad.io, but who am I to judge? Oh, I see. I have to put that context here. Monad.io of M implies... running short on time. Cannot deduce monad on left.io. Use of run resource T. We have that here now on M. I don't need this on here anymore. The monad resource needs monad.io on there, so that's staying. Okay. Oh, is there a different lift function I gotta use then? On lift.io? With run.io. Let's go to lift.io. Okay. Scoop? What's module is this? Roll monad on islet lift. And okay, gotta update the Cabal file for that. cool. That's a different error. Oh. Okay, it's getting that time. I'm starting to slip my fingers on my keyboard. Hopefully we can get this working, though, in the next few minutes. That was... Okay. Okay, I don't know if this is going to be... We have to convert everything over to this unlift.io stuff. Or do we just want unlift.io? Maybe that's the function we want. Maybe we just get rid of those. Maybe we don't need those at all. Oh, we need something. Yeah, I'm not terribly familiar with unlift.io, to be honest. I haven't used it a whole lot. Maybe we can just take resource T out for now. And do that, introduce it as a refactor if we really need it. Need to lift.io those. Maybe that as well. And then we get rid of run resource T. There we go. Okay. Don't use that anymore. Let's clean up some of these, and then I think we'll be green. Okay, let's create a little commit for that, this module, and then we'll tackle the other errors and see if we can't get green before we go. Modify client.hs. Still got some cleaning to do on this, actually. I'll just go work in progress. Boom. Added. Well, we just changed. With client. Added implementation. Add a with client implementation. That doesn't do a whole lot yet. Just connects and deinits client pointer. Okay. In here, I don't actually use that module. We're not. I think we're using that one still. Yeah, not just for the callback for now. That's fine. I don't mind merging that. Error though. Yeah, we're not using that yet, but we'll leave that in. Okay, and let's clean up some stuff here. And raw client. This is exported by... Oh, auto client. Okay, we don't need to... There, foreign.concurrent. Leftover that wasn't cleaned up. That. And another one here. Malloc. Okay, and then this client error one. Client error. Ah, we did. Okay, good. And client.hsc. There we go. That can't be right. What? No, that doesn't seem... GHC, what are you doing to me here? See if it builds. Just wait, streak a ball without any warnings. Yeah, GHC I think was just getting confused there. Okay. Well, it compiles. Ooh, wrong branch. Let me make a branch off of this one. This will be called feature with client. Okay, and then to fix this, I go back over to cluster IB branch, grab these by picking, no, switch over here, log other, fix select cluster ID, and I grab these and pick them here. Cool. And then I'm going to rebase interactively, squash them all into here, pick. Try it again. Squash those and revert that one. There we go. Also cleaned up import warnings. Okay, that's good. Then I go back to my other branch. And I reset this one. We'll set it hard. Head back 3. There we go. Okay, push that one up. Okay, we go back to GitHub. So all the code you've seen tonight for this project is up on GitHub. I'm Agent Ultra. This has been TigerBeetle HS. So it's on GitHub under Agent Ultra / TigerBeetle.hs. If you'd like to check it out, follow along, give us a star, that would be helpful. And create a little pulley request for this, but this is going to be, this is based off of fix/cluster ID. I'll create this one as a draft. Create a pull request for this one as well. This one could be a full one. And I'll get Jonathan Lorimer to review. There we go. Okie dokie. So yeah, TigerBeetle.8-HS. There we go. Library is coming along. I think we're going to start seeing things get pulled together pretty soon. Now that we got the connection going, the connection connects cleanly. We can shut it down cleanly. We don't get any warnings or errors from the server. So that's good. Well, we get the one warning that it's taking too long, but that's because like the server's expecting us like as soon as we init to initiate some request stuff. But that's because we're doing it in a REPL. It was saying we're going too slow as a warning. That's fine. But all the other warnings and stuff that we were getting at the beginning of the stream, fixed. Good. We're definitely on the black triangle path. We're going to a good place. So I usually do these streams once a week on Wednesday evenings now. I used to do them on Tuesdays, so note that down in your schedule. At about 10 after 8 in the Eastern time zone. If you prefer and you're on Twitch, give us a follow here and set up your subscription notifications and all that stuff for the stream. You'll get notified when I go online. Sometimes I do extra bonus streams, sometimes I don't. If you are following on YouTube, where I back up all my VODs on my channel, that'd be great. Give us a like and a subscribe, leave a comment, whatever. Helps the channel out. Go to the link above my head, declarative.tv. That is a website where you can find other cool streamers who are doing things in declarative programming languages. Haskell happens to be kind of fits that category, but there are other people who do Haskell. There's also people who do like Erlang and all kinds of stuff like that. So there's also a link to a Discord server on that website where there is a channel for this stream. So if you're watching my VODs, you just want to hang out, want to ask a question you didn't feel like asking on stream, hang out there, ask away. I'm always on that server. I'll get back to you as quick as I can. And what else? I think that's it. So let us end the stream here. May all your monads be free and may your types always check. And I hope to see you next week. Happy hacking out there and take care.